I'm Aziz. I'm an astronomer myself. I've finished Astronomy and Space Sciences, got my degree on that field. But for the last 7 years, I'm working as a teacher. I'm teaching astronomy to small children. Alongside, I'm doing my research, my master's on astronomy. That's basically it. Okay. The thing that I'm focusing on my research is the clustering properties of galaxies. What I do specifically is I try to look at the galaxies that are 12 billion light years away from us. So that means that when the universe was a baby, and we cannot see that galaxies really good. The resolution of the telescopes we have is not enough. So what I'm doing is just creating computer simulations to understand the clustering properties of these galaxies. The thing behind it is that we think that galaxies are formed in dark matter halos. In the beginning there were no visible matter, but in time the visible matter started gathering in the center of those dark matter halos. So that's where the galaxies are formed. When we look at the large structure of the universe, we see that it has a filament structure, like a spider web. We call it cosmic web as well. There we know from the theory that the galaxies are clustered together, but we don't know exactly whether they are clustered together as they evolved in the galaxies, or they happen to look like clustered from our perspective, because today's telescopes are not enough to resolve that far away objects when we look at them. So our main goal from this study would be, in a way, to improve how we can update our observation techniques or our next telescopes in the future to better resolve these galaxies. More, we need stronger telescopes. Soon we are going to launch the James Webb Space Telescope, which is greater than the Hubble Space Telescope. When we launched Hubble Space Telescope, it changed everything for us from scratch. We learned a lot of stuff. When James Webb goes on space, we are going to learn more and more. Just all these studies actually focuses on improving James Webb Telescope in a better way, that we will have necessary equipment to resolve what we cannot resolve with Hubble today. I don't know if you might call this the big thing, because there's a divide between researchers on this field. Like, some believe that galaxies are formed in dark matter halos, and some deny that fact. So when we learn how galaxies actually formed, when we can see the time they're formed and where they are formed, we can better understand how the structure happened, and it will help us in both ways, in galaxy evolution and about what dark matter is. Because we don't know a lot of things about galaxy evolution and how the galaxies form, how can they have different types, like elliptical galaxies, active galaxies, spiral galaxies like our own galaxy. So we are going to learn all about that. When we look at the universe, we want to understand everything, like how everything is formed, how our galaxy is formed. We cannot understand our own galaxy just by looking into our own galaxy and it formed. So the universe is a playground for us. When we look at past, and we understand how the galaxies were formed in the beginning, in order to understand how we came to be. This is, well, in general in science, this is the main purpose behind it. The thing that I'm most excited about is actually not directly my own topic in cosmology, because this is not hardcore cosmology that I'm doing, but it's rather about the Big Bang, because every time, like when we look at the universe, we try to see farther back and back. So there's a point, there's a limit that we can see, which is the cosmic microwave background radiation. This is as far as we can see, because light started forming back then. That was 300,000 years into the future after Big Bang. And there's nothing beyond that. No light, nothing. But we can understand some basics by looking at the microwave background radiation. There is a group in Antarctica, actually, BICEPS. They are trying to understand the properties of light. And how they do is they basically, in one of their research, they try to see the polarization of light. that we see in the cosmic microwave background radiation. So because if we know the polarization, we might know what happened before, whether they're polarized or not, and basically, I'm just talking so basically, what was behind that, like how they came to be, and it will be a little bit more evidence beyond, and it will be the first data beyond the microwave radiation that we see. So this is exciting for me. They achieved that result, and they published it with 5 sigma value, I guess. So that means that it's much more certain with a really little margin of error. But I actually don't know how, still when they say 5 sigma, I don't know how sure they are about their data, because afterwards there came a lot of speculations that they were a bit wrong and so on. So I don't know where they stand right now, whether they're wrong or not. So I was a bit excited in the beginning, because that was what I was mentioning, like learning some or having some data about the past period, about the early period of cosmic microwave background radiation. This would be exciting, and I was excited, and I will be excited if I hear something more. The first thing that come onto my mind is not a discovery and invention maybe, but just Galileo pointing the telescope onto the sky. That changed a lot. We started learning more and more, and afterwards just everything started piling up, and we have now living in a huge universe, and we know that. In the past it wasn't the fact, and we knew that there were less planets. The planet definition was different, the conception of the universe was different. In a way, I call it, when my grandfather was born, we weren't living in a universe that big, and we didn't have the concepts of galaxies. When my grandfather was around 20 years old, we had the idea of, oh, there are galaxies, okay, and the universe is bigger. Now, like, I'm studying this topic, and there are a lot of different topics. So I think looking up in the sky with a telescope, although not an invention, not a discovery directly, but it was the most groundbreaking thing in my opinion. And although I'm an astronomer, I don't know if that counts, if I call that the biggest thing. Every time we discovered something, it changed our perspective on the universe itself. Like for a long time ago, we had just 7 planets. Those, 7 layers of heavens, or the 7 layers of sky that we had. On those 7 layers was the moon, the sun, Mercury, Venus, Mars, Jupiter, and Saturn. And these are the 7 days of the week as well, like Saturday, Moon Day, Sunday, for instance. But as we learned more and more, we decided that some things needed change slightly. We started that change slightly. First, we said, okay, the sun. Well, first of all, let's put it in the center of the universe. We are not in the center of the universe, so it's not a planet because it's different from others. So the definition of planet changed, and then we realized at some point, like, well, Earth is not in the center of the universe, so it should be a planet. Moon, well, it moves a little bit differently, it's a bit more different, so let's not call it a planet. So we came down to 6 planets again, and then we started discovering more. Well, all the changes, and actually I'm a supporter of Pluto not being a planet, to tell that, it changed time by time. Like when we learn more about where we live in the universe, we have more and more ideas, so we every time change it. Well, of course, the most exciting recent discovery, I think, is the gravitational waves. It is just like it will be the thing of the century, I believe, because, well, we knew about it. We think that it might happen. Theoretically, it was there, and we were trying to see it. So, having discovered the gravitational waves tells us a lot about the universe and where we stand theoretically in terms of our studies and what we do. So we are kind of on a right path, and especially what Einstein did, that we knew that it's now proven with the gravitational waves. This will slightly change our perspective on gravity and physics of the field as well. So I think that was the greatest recent discovery that we had. Well, while the scientists don't approve, and already it's retired for scientists, I can say astrology, because many people still believe in astrology as a science. While it was a science before, and we were using it for calendars, measuring time, we needed to retire astrology at some point. And Well, we at least not retire astrology, but while the scientists retired it, we should carry it over to the public, to people. Like, it's not a science anymore, it doesn't have a solid background, and even astrology itself changed because the constellation in the sky changed places. The zodiac is not the same zodiac 2000 years ago, so the horoscopes and everything changed, so people should know that, and know that it doesn't have a scientific background. So the first thing that I think on my mind that will change everything would be, to understand quantum entanglement better, so that, well, if we can teleport information, just send them over long distances without using the electromagnetic waves, that would be really cool. And if we can understand, if we can do that, but just on practical, where I see ourselves struggling is the storage of energy, like batteries. Everything technologically advanced, like we have our cell phones in our pockets and everything, just we consume too much energy compared to 100 years ago. But what we couldn't improve is batteries, because we cannot store energy in a way we want. Well, while I believe that pushes us to seek for another sources of energy, more reliable sources of energies, but if we could somehow make the battery technology better, that in a way, imagine buying a cell phone and the battery lasts a month, a year actually. That's theoretically possible at some point, but we still cannot just do it. So I think that will be the most groundbreaking invention that's gonna happen. What we should be worried about is the education of children in schools, because I believe that they don't get the proper science education, which is the basis of everything. When they learn, and even deeper, when they learn to question things, when they're curious about things, they ask more and more, and that's what drives science, like curiosity. But what I believe in these days, modern times, we push the kids not to be that much curious, not to ask questions. Like, you don't ask these questions because that's already here. Just take it and accept it. Don't ask questions. It's that way. When they don't ask questions, even for wrong things or even for right things, that doesn't work for them. So I try to push children to ask more and more questions about anything they can ask. But the education system doesn't work in that way. Just it traps people, it traps children into a small area where they will know everything, where they should know everything, and they should not ask questions because that's it. And that contradicts with science. And in a way, they don't learn about science. The scientific topics are getting decreased in their curriculums in schools. So this is worrisome, quite a lot for me. What can we do to fix the curriculum is just, at some point we should leave students decide what they're going to do with the topic, with something. That's a different approach in learning. Like, I can give you an example, although it's a different field, but with medicine. There are two types of medical faculties in Turkey. In one of them, you go to the school, you learn every subject, every topic, every disease, anatomy, everything, and then at the end of the medical school, they want you to become something. In some of the medical schools, from the first year on, they face you with some scenarios that are compiled from the past patients of the university hospitals. So you get these files and you go through it, you see the complaints, and even when you don't know anything, you just like think about ideas. Okay, headache. Like, why does a person gets a headache? And this is not just only a doctor can guess. Like, in everyday life, we know why we can get a headache or the reasons of our headache. So, and as you think about it, you research your own way through it. So in 3 years time, you complete the education in your medical school, and then you go to hospital to practice it. And when you complete the 6 years, you're already a good doctor who dealt with a lot of cases on your own. So that's a different approach in science, I believe, as well. Just put forward what the students can make out of something. Don't tell them, okay, this is this and this is that. When you put them ready, they cannot dig into it, they cannot ask questions. But if they are curious, even if the questions they ask is, well, not correct, let them seek out and let them find the answer why it may not happen. Well, what I'm optimistic about is that we still have some vision, and we still have some goals, like at least peaceful goals that we want to achieve, and that we still have some inspiring people to do those kind of things. Because at some point I see, well, this is a bad side of it, but at some point I see the academia, the research science, get stuck with a lot of bureaucracy and the stuff going on around the world. I mean, the world is not just some place itself, that we cannot split research and science from politically what's going on Earth. So while we have troubles, and this, I believe the science is progressing slower than let's say the last 50-60 years. But I still think that we have some really good visions about what we want to achieve and what we want to do. So this is what I'm being optimistic about. If we can really get the speed back up again, everything is going to be great.